Hey, good evening, everyone. Time to get live again and get back to the season two. Um, got a lot of stuff to go through tonight, so hopefully I can get it done fairly quick. Where we had left off, let's see, where did we leave off? We left off with oh yeah, we added the integration tests and we added Entity Framework Core and Postgres, so we were able to test our state machine against an actual Saga repository, so that was cool. So far, we've done a lot of stuff. I guess we've had 9 episodes. We've completely built a state machine. We've gone through all the kind of different capabilities of how to interact with them, how to send requests to them, all those fun things. The one thing I realized I hadn't discussed yet, and it kind of blew my mind that I hadn't covered it yet, was we hadn't covered like how to send commands from the Saga or how to send requests from the Saga. And so that is what we're going to cover tonight. So yeah, we're going to cover two different aspects of it. One is just sending commands from the Saga and then responding to events that would be produced by the consumers of those commands. And the other one is going to be actually using the built-in request client that's part of the Saga. So I'm going to start off first with just doing kind of the send and the receive and see how that all goes. And we'll kind of go from there. So we're going to jump into the code here. I think I'm trying to find an existing place within the code base that I can kind of add this. And I'm thinking in the checkout state machine, which I know we use pretty limited because we had the reservation and the other thank you, which was doing the observations. I think thank you was purely observation based. Yeah, book reserved, book checked out, had the events, got the status, did all that fun stuff. And that was the one where we did the responses, was the thank you machine. But we're going to go back to the checkout state machine, which if we look at the unit tests for this one, when a book is checked out, and here's the case for this, we just produce that book checked out event. So it's a pretty simple use case to test from. And in the state machine, we had added a custom activity for notify member. And with that activity being in line that way, is it's running while the Saga is locked in the database. Now the notify member, all it's currently doing is publishing a notify member due date message. And that's totally fine. That's how we would send a message from a state machine. The fact that it's in a custom activity really doesn't matter. It's part of how the process works. I could have just as easily, because that's all that this thing does, is I could have just as easily, I've got something weird going on with Rider, so I'm going to pause for a second, and I think I'm going to have to kill it. So hang on. It's probably going to have to die. I enabled a plugin, and I didn't restart, and I think Rider's having a fit because of that. So let me get it back up and running here. Sorry about that. Then I have to update this, and then I have to update this, and I have to update this, and I have to tell, okay. So the code should be back on. Hopefully it's working. Okay, now we're actually working again. So glitch recovered. All right. Let's see, what do I have a question here? Nope, no question. All right, good. So as I was saying, I could just as easily, because that's all this activity does, is publish a message. I could have just as easily in the checkout state machine just done a publish within here. I could have just said .publish async, and I could have said x dot init notify member due date. Put an X here, put an X here. And let's see here, publish async. Instance type init new. I probably need, yeah. So I could have just as easily put that publish async in instead of that activity, because that's all that activity is doing, is publishing that message. Now putting in the activity lets it have dependencies and things like that, and the whole point was to show how we could resolve dependencies of that activity from container. And in fact, I guess we did. We actually did ask the member registry if the member was valid and throw an exception if they weren't valid, and handled that. Otherwise, we produced that event by publishing that event. So, there was definitely a purpose there. But we're going to use the same type of approach to send a command. And in this case, we're going to notify the member, but we're going to send a command to do something. So let me go down here. We're going to change this to here. We're going to call this update member checkout. Or let's see here, add book to member collection. I don't know, something ridiculous. And we'll go find our, hold on, where'd our published message type go? So we're going to create a command that we're going to have here, and we're going to call this interface add book to member collection. And that is going to have a book ID, and it's going to have a member ID. And just for fun, we'll probably put a timestamp. No, we won't. We're not even going to bother. It's just kind of noise. So we're going to have this add book to member collection. And back in our state machine, we're going to, I'm just going to publish this command because I know that I have one consumer in the system that is going to consume this message. So this way I don't have to figure out where the command consumer is. I can just publish it, and I know that because I own this domain, I know that I'm the only one that's going to listen to that. I have a huge Stack Overflow question on this where everyone is like, but how do I pass the address around? It doesn't matter. Just if you know that you only have one consumer in your system for the command, just use publish so you don't have to go figure out where to send it, because honestly, it's just easier. So I'm going to pass the member ID and book ID. Oop, I don't know what I did there, but I'm going to undo it. Yes. Redo. What did I do? Okay, great. There we go. All right, so we got a member ID and a book ID. Now, I need to go and create a consumer for this for one of my components. So let's go into my components. Right now, all I have is services and state machines. So I will add a directory for consumers. And then I will come in here and I will add a class of the member collection consumer. I'll try not to pound too hard on the keyboard, make too much noise, but it's just kind of how I am. And I'm going to add the add book to member collection consumer. And this isn't going to do anything right now. I mean, basically, we'll act like we did some work because, we have a really slow system. And we will publish an event. So we will go in here, and there's really no logical reason why the saga would care that the book was added to the member collection, but we're going to say book added to member collection as an event, past tense. And then we're going to publish async, or actually we're just going to context.publish because we aren't in a state machine at this point. We're going to publish the book added to member collection event. And since it's the same properties, we'll just pass the message as the initializer because we know that it's just going to copy the properties over by name, and we should be good to go. So the member collection consumer, we're going to have to add that for our test that we're doing. So we're going to create a new test. So we're going to go over to our checkout state machine test fixture. We're going to steal one of the simple tests here. And we're going to go down to the bottom and add this in and rename it. So we're going to call this when a book is checked out by a member, it should add the book to the member collection. Great, awesome. We're going to create a book, we're going to create a checkout ID. We have a book ID, we have a member ID. We're actually going to have to probably save this member ID so that we can verify some things later. And we are going to publish the book checked out. We don't care about the test harness doing these things. All we care is that the saga harness exists, checkout ID. All we care about is the checkout is in the saga. We don't care about when it got there. And we're going to verify that we aren't going to verify that was published, but we are going to verify that our new event was published. So our add book to member collection, we're going to verify that that was published. Add to collection not published. So we will run this test. Hopefully it will work. And it did, which means we actually sort of did something right. We look at our log again because we have all the logging turned on. You can see that we sent the message, we received the message. Our consumer did not do anything because we don't have a consumer and we didn't even check that yet. So to get that working, we actually have to, in the configure services, actually there's another one we have to do in the override of configure MassTransit, which if I remember right, there's nothing in there, so I don't have to call the base. I just don't call bases, sorry. If I know there's nothing there, I'm not going to call it, it's noise. And I am going to say configurator.add consumer, member collection consumer. What was it called? Member collection consumer, there it is. So this should add the consumer, and if I rerun the tests, I may see the message actually get consumed. I'm not positive I will though. Yeah, probably not. Let me check the setup. We did create the receive transport for the member collection, so that's definitely going to be there. We have some yummy squirt stuff. So the consumer is there. It's just because we didn't wait, it actually didn't finish processing it. So let's see. Let's go back to our test, and we'll add a test to find out if consumed includes that add member to collection. Add not consumed. And what this will do is then it'll wait not only that it was published, that it was actually consumed by a consumer. And it was. Okay, so now we look and we can actually see that we have a receive that the add book to new member collection was consumed by the member collection consumer. And then it actually produced the event this time of book added to member collection. Now, I'm not going to go into a whole lot of detail on the state machine consuming that event because we've kind of been doing that since the beginning. The state machine has all those events in it. But one thing I did want to cover, and because I'm not tracking any sort of state on here, I'm not keeping track or moving to a state. But I wanted to show as one of the capabilities of the state machine is what happens if that fails? How do I catch that fault? So what I'm going to do is I can't really put a random in here, but just to kind of make it fail, if the book I'm gonna create it so I can do this in the, I can't do that, dang it. Making things break on purpose is really tough. So I think what I'm gonna do to make this happen is I'm going to take this consumer and I'm going to go to my test fixture. So I have the working test. I can verify that I publish that and the event gets published. And I can actually come in and let me I'll just rename that. And I'm going to put the consumer in here because what I'm going to do is I'm basically going to create a faulting consumer and add that one instead. So I'm going to call this the the bad member. Collection consumer, and all this one is going to do is throw an exception. Valid operation exception. The member is overdrawn, which is a very banking term, but whatever. And I'm going to put the bad member collection and consumer in here. And again, because I've published this, it doesn't matter. I have one consumer for the command that I'm registering on the container element for this. And the whole point that I'm trying to do is when the book is checked out by a member with fault, and the other thing I want to verify here is that we actually published the other event, book added to member collection. So if I run this test again, we'll see that the real consumer did its job, which we really shouldn't be inserting that, but we're verifying our state machine. But it published its event, and we want to make sure that we actually consumed that. Well, we're not consuming it yet because we haven't updated the state machine to do that. So if we run that now, without that, without the state machine consuming it, it wouldn't do anything. We would just say, hey, you didn't consume it, so what's going on? So we're going to add to the state machine where it consumes that. So the first event we're going to add is the book added to member collection. Added to collection. And we aren't going to do anything with it. We're just going to kind of, if this was something where we were going to capture some data on it or something, we would just put at the bottom a during any. And then we would say when added to collection, we would just basically say thanks. Yeah, we're not going to do anything. I don't even know if that works, actually. We would probably have to do something. We'll just say ignore. Why not, right? We'll do something fun. We'll do something fun like nothing. Because I don't really care. I just want to consume it. If I was doing something with it, that would be great. The whole point is that I want to show that it gets consumed. You notice I turned on my presentation assistant, so the keyboard shortcuts are showing up. Added to collection was not specified. Oh, right. Because I don't correlate that. Yeah. So because I added that event, I have to correlate it back in. And we're going to do that by book added. What's it called? Added to collection. Because we didn't correlate added to collection, we have to tell it to correlate by something. We can't correlate by checkout ID, and now we can't correlate by ID. So we have to say correlate by I don't know if this will work or not. Let me find out. I think there's two things I have to put here. So because this message is correlated by something else, I think I have to do two different types here. I think I have to say instance dot book ID. And then context dot message dot book ID. Maybe. GUID must be a reference type to use it as parameter T. Boy, that doesn't sound right. Does that work? Yes. Hey, there, that works. Wonder if this will work. We'll find out. We're just going to correlate it by book ID and see if we consume it and see if it works. We might never get it. Who knows? Saga used, yeah, it used the existing instance. So it did correlate, and it correlated because we're in memory. It obviously won't work with Redis because we're correlating by that. In fact, we should probably even change this expression to be even better. So let's change this to be something that we would actually use. Correlate by. Why is this not doing this? Text.correlate by context, comma, instance. or instance, comma, text. Can't remember which order this is. Instance, comma, context. And we want to say instance.bookid equals context.message.bookid and instance.memberid equals context.message.memberid. So we've added in the full expression for this correlation that will then be used to build a link expression to query against the repository. So we will pull that in and we will correlate to that, and we should get a pass and everything is great and it matched to it. So that's the event that we get. Now we want to test the negative case. And if we go back to our test, you can see that I added one for at the bottom for bad. Basically, when I check out the member with the fault, should handle the fault message via correlation, whatever. But the whole point is now the message was published, but we aren't going to get that message back because we added our bad consumer in here. So if we run this test now, we're going to see two things. We're going to see two tests fail. We aren't going to have published that event, and it's going to fail on that first assertion because it didn't actually publish book added to member collection. So that's a bad thing. But what it does do is, because the way MassTransit handles faults, whenever a consumer faults, it's going to publish a fault event. So what we will do to handle that fault within our state machine is we will add a fault handler as an event type. So we'll close this out here. We'll go down to the bottom. And just like we had here, we will add a fault for the add book to member collection, because the fault add to collection faulted, because the fault type is based on the message being consumed, not what I would have expected. So, obviously it doesn't know that. I will also have to come in here and is it add to collection faulted? What do I call it? Add to collection faulted. And the correlation is a little wonkier on this one because the message parts of the expression, when you get a fault, if I look at the fault, it's a fault of T. It has its own properties. So the actual fault message in the context includes the fault ID, the faulted message ID, which is the transport message ID of the message that faulted. It also includes the original message, and any exceptions that have occurred show up as an exception info, which is MassTransit's serialized version of an exception. In this case, I want to just go to the message and get the book ID to correlate, and the same thing here. So I get a full copy of the original message that was sent as part of that command when a fault is published. So I'm going to correlate that back down. And in this case, I'm going to say, again, during any, because why not? When add to collection faulted, in this case, I'll do something like, I don't know, let's do a test context. No, I can't do a test context in here. I'm just going to do a console write line, whatever. Add to collection faulted. I don't want to change the state at this point. This is just kind of an observation thing. Now if I run this test, I should see that the proper messages were not consumed because I didn't change the assertions of the test. But I should see that published of fault add to collection, fault not published. And I should see that we consumed the fault. We'll run that test again. This time we should see it pass because we're actually getting those messages. Okay. And we can see down here in the log, we got a fault that the message actually faulted, the consumer faulted, the invalid operation exception, the member was overdrawn. The saga used the existing state machine instance and correlated to the fault of add book to member collection event. So we were able to handle that event within our state machine, and it serves that we consumed that. I think maybe if we go look at the top, I don't know if we'll see any console write lines or not. And yeah, there it is. Add to collection faulted is in the console write line right there. So that was fun. Yeah. So that's how we send commands. I mean, obviously we were doing that in the activity before, but just sending a command out from the state machine. The state machine, the consumer of that event, of that command, produced a fault that we were able, at first, you know, we produced the event that the message was added, and we added that in. It also threw an exception, which produced a fault, which is published out, that we then correlated back to the state machine to handle as well. So both of those are things that are pretty common, especially when you're using a state machine to do actual orchestration. So that's that part. The next piece I want to show is how to do requests from a state machine. So requests from a state machine, when you're doing requests, and we did requests elsewhere in the system where we use the iRequest client, where you pass it the message type and then you tell it the valid response types and all of that comes back. You can't use the request client like that with a state machine. I mean, you could, technically you could, but you're going to be holding that database lock on that Saga instance the entire time the request client is sitting there. And one of the advantages of Saga, the whole reason that the Saga pattern is used within MassTransit, is because between messages, we're able to let the Saga repository keep the state of that consumer, freeing up that call stack and that thread and that message on the transport to be available to process another message. So we complete the message that put the Saga, that was handled by the Saga, and then we persist the state out, complete that message, and free that up for another Saga instance to run. And that's how we keep our Sagas. First of all, we keep the database happy because we're keeping that lock time as low as possible, or just reducing the window for an optimistic concurrency exception. But we're also making it so that more can go through at a time, because if we're blocking anything, you know, there's a prefetch count and a concurrency count that's set for a receive endpoint, and that's how many you're going to process at a time on that endpoint. So we wouldn't want to use the request client because it's going to block, just like we wouldn't want to do any long jobs within that Saga. That's why we send commands out to other consumers to do that work for us, so that we can spread that out and prevent the Saga from becoming a bottleneck in our system. So the next thing is, how can I then do a request from a state machine in a way that I'm allowed to handle that, but let the Saga repository deal with persisting the state and managing that request state. So let's look at the state machines that I have in here. We have the thank you state machine, which I'm trying to remember one that does something fun. Book checked out, get status. This was the one that we did the composite event and everything on, and that's right. We don't want to use that one for that. So let's see here. What do we got? We got the reservation state machine. When book reserved. Yeah. Didn't we have a reservation extended? Did we extend the reservation? I thought we had a place where we extended the reservation. Book reserved. Is that on the book state machine? Reservation requested, reservation canceled. Yeah, I'm trying to remember where we put this code, because I know we had oh, this was the renew checkout. Okay, that was when the request came into the state machine. Yeah, that's a tricky one. So let's see here. What do we got in the reservation state machine? It's got a lot of complexity. I'm almost thinking I want to create a new one, but that's going to put a lot of time, and I might do an episode break and come back and create the new one to show how to send a request from the state machine. Yeah, because I don't really want to grind through creating an entire state machine, because we're going to end up at almost an hour for the episode, and I'd rather keep it at about, if I could get it quick in 10 minutes, I would. So yeah, I think what I'm going to do is I'm going to take a quick break. I'll come back again in about 10 minutes. I'll go ahead and set up a new state machine that we're able to send a request from, and I'll continue with that. So give me about 10 minutes to take a break. I'll come back on and we'll kick off the next episode that'll be sending the request from the state machine. So we discussed how to handle events and faults in this one. Hopefully that was pretty useful. I'll break this up so that we're able to more easily address it, as far as different videos. And we'll catch you back here in about 10 minutes. All right.